Hi guys, it's Mrs. Rice. This video we're going to introduce trigonometry. So when you're doing trigonometry, you need to know the hypotenuse and what the opposite side and the adjacent side of an angle is. So first thing I'm going to do is just break that down for you. So the hypotenuse is always the longest side of the triangle. It's always the side opposite of the 90-degree angle. So here's my right angle. Here is the side opposite. Okay. So this is the hypotenuse. Here, we'll do it this way. There we go. So the hypotenuse will always be the longest side. When we're referring to opposite and adjacent, we're only referring to the legs of the right triangle, and the opposite and adjacent sides change depending on what angle we're focusing on. So if we're focusing on angle C, then the adjacent side would be BC because it's the side that has that letter as part of its side. And then the opposite side would be AB because that letter is not in that side at all. So hypotenuse will always be the side across from the right angle, always the longest side. And then whatever angle you start with, so say they tell you angle C, the adjacent side will be the side that contains, or the leg that contains that letter. So the leg that's right next to that angle. And then the opposite side is the side across from that angle. So see how here C and AB is across from C. And the opposite side will never contain the letter that they're talking about. So this would be the triangle structure if we were talking about angle C. Now, if we were talking about angle A instead, then we know that this would still remain the hypotenuse, but this side would be the adjacent side. And then this side would be the opposite side. There we go. And again, it's because angle A is the focus, right? So which leg has angle A as part of it? AB. Which leg does not have A a part of it because it's across from it? BC. So that's just focusing on adjacent versus opposite. Okay, so I'm giving you these three triangles. Answer the questions on the right side. I hope that was easy. Okay, so now there are three trig functions we have to talk about. One is sine, spelled S-I-N-E, but when we write about it in these problems, we're going to call it sin. And the second one is cosine, but when we write about it in our problems, we're going to call it cos. And our last one is tangent, and when we write about it in our problems, we're going to call it tan. So this SOHCAHTOA is a mnemonic device to help us remember how to set the problems up. So that's what I'm going to do now for you. So sine is the first part of SOHCAHTOA. So sine of an angle, so this is theta. Theta represents an angle measure. So sine of theta, sine of some angle, equals O stands for opposite. H stands for hypotenuse. So the sine of some angle, measure or letter, will equal the opposite side length of that angle over the hypotenuse length. So that's how we'll set up our fraction. So that was so. Okay. Put these back. Talk about the next one. So the next one we're going to talk about is cosine. So the cosine of an angle, again, we call this symbol theta, It represents an angle measure. So cosine of theta, or an angle, is equal to, and in this fraction, we have A, which represents the adjacent side length over the hypotenuse. So O represents opposite side length, A represents adjacent side length, and H represents the hypotenuse. So cosine of an angle measure is equal to the adjacent side length over the hypotenuse. And then last, but certainly not least, is TOA, which is tangent. So tangent of theta, again, tangent of an angle measure, is equal to the opposite side length over the adjacent side length. So, SOHCAHTOA, reviewing that. SOHCAHTOA is a mnemonic device to help us remember how to set up these trig problems. Sine is the S, so sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent. Okay, so let me show you how to do this. So we'll start with the cosine of O. So the cosine of O, so that's our angle at this point. We don't have a measure for it, so we're just going to identify it. The cosine of O is equal to, so think of SOHCAHTOA for a second. Ka, this is ka. So cosine of an angle is equal to the adjacent side. So EO is the adjacent side, so that's 4 over the hypotenuse, which would be 5. So if we were writing the fraction that represents the cosine of O, we would be writing 4 over 5. I hope that makes sense. Okay, let's do instead the cosine of G. So let's put these numbers back. We'll leave that there. Okay, so the cosine of G. So here's G. So the cosine of the angle G, adjacent, so that's 3. Hypotenuse, which is 5. So the cosine of G is equal to 3 over 5. I hope this is starting to make sense if you were confused before. Okay, let's return these. All right, let's do more. So the sine of angle O. The sine of angle O, that's the SO in SOHCAHTOA. So SO is sine of an angle equals the opposite side over the hypotenuse. So here's O. So O, the opposite side is 3. The hypotenuse is 5. So the sine of angle O is equal to 3 over 5. Pretty easy, right, guys? Let's do the sine of G. Here we go. The sine of G. So here's G. Sine of an angle is equal to opposite, so that's 4 over the hypotenuse, which is 5. So the sine of angle G is equal to 4 over 5. All right. And then the last one is tangent. So you'll see tangent is the only one that doesn't use the hypotenuse. So that's always good when you're trying to figure out how to set up the problem. So tangent of angle G. So tangent's represented by TOA. So tangent of an angle is equal to the opposite leg over the adjacent leg. So the opposite leg of G is 4. And the adjacent leg for G is 3. So 4 over 3. Hopefully that made sense. And then last but certainly not least is the tangent of O. So the tangent of O is equal to, again, the opposite, which is 3, over the adjacent leg, which is 4. So the tangent of angle O is equal to 3 over 4. So I hope that makes sense for you guys. Now, if you look, here's this picture. Answer the questions on the right side. Hope this helped, guys. Bye.